Hi all, this is Rajiv and Jung from PhD Expertise, and today we are excited to be with our guest, Dr. Brian Setzler. So Brian is a PhD Chemie graduating from Georgia Institute of Technology in 2015. He's actually an expert in fuel cells and the battery space, although I would say he might hedge on that battery space portion, but don't believe him on that. And he's got multiple publications in journals like Nature Nanotech, Journal of Electrochemical Society. Actually, we have a couple publications together, so super excited to have him. And the big thing that we want to talk about today with Brian is he's a co-founder of an anion exchange membrane and electrolyzer company called Versogen. So thank you, Brian, for being with us today. And I will kick off with an important question for most of our viewers. Just give you a little bit more context, Brian. Our viewers are mostly people who have either recently completed their PhDs or are working on their PhDs. So we know that you went to Georgia Tech for your PhD, and your advisor was Dr. Tom Fuller, who is an expert in the battery and fuel cell space. He's well regarded for math modeling and testing of lithium-ion batteries and fuel cells. And so at Tech, with your exposure to Dr. Fuller and his group, what were your main areas of focus? What kind of work did you do over there?
Well, thanks for having me here. Nice to be with you guys today, Rajiv and Jung. And at Georgia Tech, my main area of focus was modeling of proton exchange membrane fuel cells. I focused on kinetics and mass transport mechanisms in there. One aspect of it was looking at the effects of the platinum oxide layer during electrochemical impedance spectroscopy measurements, looking at some of the discrepancies that come up there, as well as looking at the effects of liquid water condensation in the cell and subsequent two-phase flow, and looking at water and heat generation in the cell.
Okay, very, very, very nice. So in your time at Tech, so you worked pretty closely with Dr. Fuller. What were some of the things that you were trying to accomplish with the work that you were doing, the projects that you were on? Were there any special projects that you undertook or anything that you'd like to sort of highlight about the work that you did that you feel was impactful?
Yeah, typically the broader focus of our work was understanding the degradation mechanisms within proton exchange membrane fuel cells, and then trying to improve that durability. So for example, one of the reasons why we cared a lot about the platinum oxide layer was that there's an important interaction there with platinum dissolution, which is a mechanism that leads to degradation of the catalyst within the fuel cell. It's one of the things that limits our ability to go to lower platinum loadings in PEM fuel cells. Similarly, with two-phase flow in liquid water, one of the concerns there is how the porous structure of the catalyst layer changes due to degradation, things like carbon corrosion, and how that impacts those flooding losses. I would say that my research focused more on the performance side, and I didn't actually get to answer all of the questions that I set out to answer about durability, but that was definitely the broader push that those projects were part of.
Yeah, and I think one of the things that was really interesting about being able to work in Dr. Fuller's group was that we had the opportunity to work on industry-related projects, right? And I think you had an experience with an auto manufacturer. Can you talk a little bit about that as well?
Yeah, so early on in graduate school, I was on an SF grant, but then I was transferred over to a Toyota-sponsored project, and so we would talk with the group there. They gave a presentation at Georgia Tech one time talking about their progress with the Toyota Mirai. This was a couple of years before they released that commercially. So that was really interesting. I mean, certainly they weren't really, we weren't really in on proprietary information, I wouldn't say about that, but, we got a lot more perspective from that industry collaboration. I think that was pretty useful.
For sure.
All right. So Brian, I learned you and your advisor co-founded the company called Versogen. Can you tell us about how and why you decided to pursue this opportunity?
Yes. So we founded originally as W7 Energy and now Versogen. And we founded this company at the very end of 2017 really kicked off in 2019, though. This, my advisor, Yushan Yan, a long time goal that if you ever ask him, he'll tell you about, has always been to see one of his technologies get out into the world and be commercialized. Like, he wants to see something that started in the lab actually grow up, go out there and be deployed. And, I also felt that way, especially after some of the modeling work that I did in graduate school, which, I enjoyed a lot. I still do enjoy, but it was a lot of thinking about small details of the fuel cell and not really seeing the direct impact in our everyday life. And so it was pretty exciting to have an opportunity, really not thanks to me, thanks to the hard work that had already taken place in the group to develop a new set of materials, to have this opportunity to go, we went to a toll manufacturer, we made rolls of membrane. I'd never had that experience before, and that was pretty cool. So yeah, I think it was just an alignment there between Yushan's long-term goals and also what I was interested in. And the founding team was a lot larger than just Yushan and myself. There were 7 of us total, quite a few members of the Yushan Yan group. A few of the other ones have been really pushing the company forward these days.
Speaking of membrane, can you tell us a little more about your key technology, the polyaryl pyrrondinium-based anion exchange membrane, and what are some challenges you face scaling it up?
Yeah, absolutely. And this was really part of the opportunity. So anion exchange membrane, this field is relatively new. There's been a lot more interest in the last decade. For quite a while, there was a sort of a benchmark material made by Tokuyama Corporation. And this was the closest thing we had to an Amphion equivalent. It didn't really meet the final device requirements for the field, didn't have the level of stability or performance that we needed, but it was really the only commercially available membrane that was even remotely close. And they actually had a little bit of a strategic realignment and went another direction. Not that I know the details of that, but basically at the time that we founded W7 Energy, there really wasn't any commercial availability of anion exchange membranes. At the same time, there were a couple of different breakthroughs in our lab, as well as in some other labs too, with new classes of materials that were really, I think it's fair to say, an order of magnitude more stable than what we'd had in the past. And this was combined with good performance, high conductivity. So this was one of those first materials that was really put together the combination of mechanical robustness, good chemical stability, and very good performance that we needed to start to get more serious about these anion exchange membrane fuel cells and electrolyzers. So there's really an opportunity there because if nothing else, the field just needed some commercial materials just to be able to drive our research forward. A few years ago, basically, if you wanted to do research in anion exchange membrane fuel cells or electrolyzers, you needed a collaboration with a group of polymer chemists who were making you your membranes. It wasn't like in the PEM fuel cell world where you can just hop online and buy the commercial materials. So certainly we're not the only ones doing this, and we have some great competitors out there, but that's what we're doing, making these materials available. And I would say now we're getting a lot more excited about some of the commercial opportunities beyond just making membranes to have for research, but actually getting into real devices and real products.
Wow,
So Brian, are you working on elements of that as well? It sounds like there's a sort of a business case that's being put together to be able to push this forward and actually get that scale.
Yeah, so early on, I helped quite a bit with scaling that membrane up. We were making it in our lab. We'd make it at, say, 50-gram batch size in reactors on the benchtop. And, we'd cast membranes on a single glass plate, similar to what other people do. And if we wanted to be able to sell something, we needed much larger scale for polymer synthesis. We needed to be able to manufacture it in a roll-to-roll process. And there were just a lot of practical difficulties with that scale up. Most of them were not, very complicated chemistry, but just really standard chemical engineering, I would say. And so helped with that process. I would say in the last year or two, my focus has been more on the application side. And here, most of my assignment is still at University of Delaware on the academic side. But we're developing fuel cells, electrolyzers, and CO2 separators that are all built around these membranes and ionomers. I've especially had a focus on the CO2 separator side. We've had some pretty fun ideas there that are a little bit new.
Okay, so your focus is still more of the academic portion of this, but there is an opportunity that you see yourself sort of making more of the business case and developing out where the opportunities are in the market and looking to place the product somewhere, working with other organizations to do that, partnerships and things like that.
Yeah, all of those things are happening, and they're just not my primary responsibility right now. But we have other people from our group at Versogen who are doing a great job of leading the business forward.
Okay, no, that's super interesting. I think one of the things Jung and I always discuss about is that it feels like sometimes there's not enough opportunities for PhDs to do a little bit more than they're actually, just the academic portion. But it sounds like if you wanted to, you could have a little bit more of a say, make a little bit more of an impact in the business case, and that's exciting, right? Because we should have as many opportunities as we can to really make that impact. So that's super awesome.
And one of the things that really helped there, we had a lot of support from ARPA-E, part of the Department of Energy. And that's really their mission, is to take promising new technologies and get them to the point where they can be commercialized. They're a little different than a lot of other federal agencies. They're not so much focused on pure science, but they really want to see the commercial potential. So even part of those awards is dedicated to technology to market activities. So everything that, it was well aligned, basically, the funding for the research was well aligned with the goal to actually get this out into the marketplace. And we certainly owe a big debt of gratitude to ARPA-E for the funding on that.
Very nice, very nice.
Yeah, so speaking of the academic, your research work, and then a lot of our audiences are current PhD students. Can you give them some lessons you learned for being a good, productive postdoc?
Yeah, so maybe there's two bits of advice there. I guess the first one is, I think as a postdoc, you have a little bit more perspective than you did your first year as a graduate student. And you want to use that and keep your research focused towards what you see as having the most impact. I don't want to be cynical and say impact factor, but really, what's going to be interesting about your work, and what's going to make it more broadly applicable. One of my first experiences in the postdoc was writing a paper where part of it was just this very simple 1D model. It was almost a homework assignment. And I got more engagement and more positive feedback from that model because of the analysis that we used it for than I did on my graduate school work, which was, years of work focusing on details and far more technically complex. So, it's not all just about the technical complexity, but you have to think about what you're learning from it as well. And, maybe I was learning more from this simple model than from the more complicated one. Maybe the second bit of advice is just that, I think sometimes in graduate school, you stay busy and you have deadlines and you think you're going to power through it, and then, can't wait till you get your job. But I think each job comes with a little more responsibility than the last, typically. That's not really going away. So I think you have to live in the present a little bit and find yourself a balance, find a lifestyle that you're happy with.
That's awesome, Brian. Thanks for giving that advice. That's it's one of the challenges that I think every person faces in general, is like not living in the present and always thinking about what the next position is or the next thing they're going to try to accomplish is. And so being able to enjoy that, relish that moment is I think really helpful. And the one other thing I'll say to some of your comments was, I remember the inductive loop and all the effects that you try to model out. Totally understand that 1D model, I think we talked about that too, that 1D model is so, it was challenging, but it was great at the same time. So I'm glad that worked out for you.
Thank you.
Yeah, so Brian, we really appreciate you being with us today. And thanks to everyone for watching this video. And if you have any questions for Brian or for us, please send them to PhD expertise team at gmail.com. And stay tuned for our next episode.
Thanks, everyone.
Thank you very much.